Okay, we're still talking about brain pathways. It's starting to get interesting. Or confusing, depending on how you look at it. So we'll try to clear up the confusion. So we talked about the conscious relay pathways and the information that is transmitted in the dorsal column and the information that's transmitted in the anterolateral column. So the dorsal column is mostly or largely conscious relay pathways. The anterolateral column is conscious relay pathways that we talked about, spinothalamic, but it also includes divergent pathways. So the anterolateral column has more diverse information traveling in it than the dorsal column. So we talked about how if with the spinothalamic pain, it's acute pain, it's quickly localized. With the divergent nociceptive pathways, it is less well localized, so the entire area seems to hurt. The first order neuron in those divergent pathways is a small, unmyelinated or less myelinated C fiber. The receptors are free nerve endings, and those guys are sensitive to noxious heat, chemical or mechanical stimulation. So these are nociceptors. These are the things that are receptive to things that could potentially damage tissue. These first-order neurons have high threshold C fiber endings that become sensitized with repeated stimulation. So this is going to play into chronic pain that we talk about in the next chapter, in chapter 12. The ascending projection neurons, this is our second-order neuron. The axons of those ascending projection neurons, which run in the anterolateral column, reach the midbrain, the reticular formation, and the limbic areas via 3 tracts in the anterolateral spinal cord. So the 3 tracts are the spinomesencephalic, the spinoreticular, and the spinolimbic or spino-emotional is the other name for it. So let's just dissect those words a little bit. Spino, obviously is spine. Mes is middle, and encephalic is brain. So spine to midbrain is that spinomesencephalic. Spinoreticular, the reticular system in the brain has to do with our level of arousal and awareness. So it goes from the spine to the reticular system. Spinolimbic or spino-emotional goes from the spine to the emotional system, or the limbic system. The tracts are parallel ascending tracts. Only the information in the spinolimbic tract is perceived as pain. The spinomesencephalic tract has different effects, and the spinoreticular tract has different effects. So only the information in the spinolimbic tract is perceived as pain. Interesting. We're going to talk more about it. The spinomesencephalic, so we're still talking about spine to midbrain, carries nociceptive information to, and you don't need to know this level of detail, but we're talking about it, to the superior colliculus and the periaqueductal gray area, also known as the PAG. The PAG is part of a descending pain control system. So in modalities class, when we were talking about that low rate TENS, and that has the acupuncture-like effect, it is thought to, although it's not been proven to, but it's thought to affect the periaqueductal gray area and activate the descending pain control system. So that spinomesencephalic tract, it does that. It activates the periaqueductal gray area for descending pain control, and it's also involved in turning the eyes and head towards the source of noxious input and activating descending tracts that control pain through the PAG. So, in the midbrain, what do we have? We have a lot of stuff in the midbrain. We just very briefly talked about it in chapter 2. But one of the things that we have is the cranial nerves. And one of the cranial nerves is the spinal accessory nerve is attached to the upper trapezius, which turns the head. So the spinomesencephalic tract is that nociceptive information activates those cranial nerves that turns your head and eyes towards the source of the noxious input and then it activates the descending pain control. So even though this doesn't happen on the conscious level, it's pretty important, right? So the Spinoreticular Tract, the ascending neurons in that tract, they synapse in the reticular formation. The reticular formation is a neural network in the brainstem that includes reticular nuclei and their connection. And they modulate arousal, attention, and sleep-wake cycles. Have you ever had pain after an injury? I know this is a stupid question because I know we all have had this. That keeps you awake at night. Doesn't this make sense that the spinal reticular tract is transmitting nociceptive information to the reticular formation, which modulates arousal, attention, and sleep-wake cycles? Makes sense. The spino-emotional tract, also you will see it called the spinal limbic tract. The axons of this tract transmit slow pain information to the medial and interlaminar nuclei in the thalamus. Do we care about the nuclei? No. We just know it goes to the thalamus. So we know if it goes to the thalamus, it has the chance of getting into conscious perception. The slow pain pathways provide information that produce automatic movements and autonomic and emotional responses to noxious stimuli. Activity in the spino-reticular and spino-emotional tracts result in arousal, withdrawal, autonomic, and affective responses to pain. So affective responses to pain are, crying, grimacing, I'm so upset that I'm in pain. That's the emotional part of it. And as you know, in some people, that is a bigger factor than the actual tissue damage. So we have subconscious temperature information that's transmitted in older pathways. They say phylogenetically older pathways, meaning they develop earlier in the brain. The reticular formation, they transmit the subconscious temperature information to the reticular formation, to the thalamus, to subcortical nuclei in the below the cerebral cortex, and to the hypothalamus. Remember that the hypothalamus is a big deal in maintaining homeostasis, so that subconscious temperature information is going to help. It doesn't reach our conscious awareness, but it contributes to arousal, provides gross localization, and contributes to autonomic regulation. So a lot of that subconscious or unconscious information is activating systems that are going to help us maintain our homeostasis. So in the next section, we're going to Okay, in this next section, we're going to talk about non-conscious relay tracts to the cerebellum. So we have non-conscious relay tracts to the midbrain and to the reticular system, but now we're going to talk about the non-conscious relay tracts to the cerebellum, and their job is to transmit information from the proprioceptors and information about activity in spinal interneurons. So they relay information that's critical for adjusting movements. If we have inadequate proprioceptive input, that can cause sensory ataxia because of the loss of sensory feedback, disrupting movement control. So all of the information, the cerebellum is getting a ton of information from the body, and its job is to make those tiny little adjustments back and forth, that keep us making movements that are accurate. It helps with postural information, it helps with balance. All of that non-conscious stuff is going on in the background. We're not even aware of it. So the somatosensory pathways provide information about the external world and about the musculoskeletal system. Conscious information about external objects can be provided by all four types of discriminative sensation. The medial nociception system provides information about stimuli that threaten to damage or have damaged tissue.